Okay, so let's do some proofs. Now, when we're proving identities, we are essentially saying we want to show that the left-hand side of an equation is equal to the right-hand side of the equation. Okay, so in this case, we want to show that this is in fact equal to cos squared of theta. Okay, so when you are proving an identity or proving anything in general, you're not treating this as if it was an equation or if it were an equation. Okay, so you don't want to move things left and right or do anything like that. What you want to do is you want to show that the left-hand side is equal to the right-hand side. Okay, and by doing so, what we're going to do is either do something with the left side or do something with the right side. Now, looking at the right side, we can see, well, there's not too much we can do with that. So what we might do, in fact, is we might look at the left-hand side. So we're going to start off by writing LHS because we're going to be working with this, and it's good to label the stuff as we go. 1 plus sine theta, 1 minus sine theta. Okay, well, let's expand this out and see what we get. 1 times 1 is 1. 1 times negative sine theta is negative sine theta. Okay, sine theta times 1 is positive sine theta. And sine theta times negative sine theta is negative sine squared theta. Okay, so now doing some cancelling, we're going to cancel that with that, and we get that this is equal to 1 minus sine squared theta. Okay, so what we need to do on the way down to is actually explain what we're doing step by step. So when you're doing a proof, it's not enough to just do something. You have to, in most cases, explain what you're doing. Expanding left-hand side is a bit overkill because realistically we can see that, and I wouldn't actually write down simplifying minus sine plus sine because we can see that. If it's a logical algebraic step where we get from one step to the other, it might, it makes sense. However, if I was then to do something like that, because I know that this statement is true, we need to justify why we can do this step. So we can do this step because I know that the Pythagorean identity is, or Pythagorean identity of cos squared theta plus sine squared theta is equal to 1. Or in other words, that cos squared theta is equal to 1 minus sine squared theta. Okay? And that is enough to actually prove that, because we know that cos squared plus sine squared theta equals 1. So if I rearrange the Pythagorean identity, I can get cos squared theta is equal to sine squared theta plus just lost my train of thought. So yeah, if I know I can rearrange it and get that value there. And then to finish it off, we know that that's equal to the right-hand side because that's what the right-hand side is equal to, okay? So all that was basically taking one part of this equation, if you will, and just doing stuff with it until I get where I want to go, okay? So we're going to do this again, and we're going to do this for some trickier ones. So that one was nice and easy because what fell out was a Pythagorean identity straight from the get-go, okay? Or with a few steps. This one is a lot harder. And as I say a lot harder, it's not that much harder if you've sort of got some grounding on where to go. But nonetheless, it's still something that we can, play around with. So let's start off by looking at the left-hand side, okay? So what I'm going to do is I'm going to write it down. So tan theta, sine theta. So remember, if they're next to each other, it means times. So sine theta times tan theta times sine theta plus cot theta is equal to sec theta, or theta, however you want to pronounce it. Sec. Okay? Oh, no, sorry. Ugh. We're only worrying about left-hand side. So that is equal to. So what do we know about this? Well, cos and sine are pretty straightforward things that we don't want to do too much to. However, I know that tan theta is equal to sine theta over cos theta. Okay? No, it's the other way around, isn't it? No, that's it. Okay? So what I'm going to do is I'm going to rewrite this as, instead of tan theta, it's going to be sine theta. So it's going to be sine theta over cos theta times sine theta plus cos theta is equal to, and we're going to leave it as that, sorry. Okay? And then over on the side as tan is equal to sine theta on cos theta. Okay, so just explaining what I'm doing as I've done that step. Okay, now the next step is just going to be a little bit of manipulation and rearranging, so there's not too much I need to do for this one. So what I'm going to do is I'm going to put the signs together, because remember, this is technically over 1 and there's a times between the two. So what I'm going to do is I'm going to multiply the tops, so sine times sine, which is sine squared theta, times the bottom, so cos over, cos times 1 is just cos. And that is equal to cos theta, okay? Or cos theta over 1, because what we're going to do now is we're going to add these two identities together, okay? So again, because we're just doing some algebraic manipulation, we don't actually have to explain what we're doing, okay? So we're just adding some fractions together. So what we're going to do is going to make a common denominator. So cosine plus, times 1 is just cosine, okay? So what do I do the 1 to get to cosine? Well, I times it by cosine, so I do the same to the top. So plus cos of, or in the other words is cos times cos is cos squared theta, and then 1 times sine squared is just sine squared theta, okay? So remember to cross multiply times these two, times that, okay? Nice and easy. Okay, now you might be saying to yourself, oh, I can see something here. There's a Pythagorean identity on the top. And you would be correct, because sine squared theta plus cos squared theta is just equal to 1. So this is the same as 1 over cos theta, okay? But what is 1 over cos theta the same as? Well, that's just the reciprocal function of cos, which in other words is sec theta, okay? And that is equal to our right-hand side. So just again, doing a little bit of manipulation, we can actually prove that this identity exists. So tan theta times sine theta plus cos theta is the same as the reciprocal, or 1 over cos theta, which is really cool, okay? And I just like to add as required because it makes me sound pretentious. So that's sort of some bare bones on how to actually prove these identities. So most of the questions that you guys will be answering are to do with proving these identities. Okay, knowing the identities, which we did in the other 3 videos, is just to get you guys introduced to them, what they look like, and how we got them. These are the types of things that you're going to be actually asked to do, is actually to show that something is equal to something else by doing some trigonometric, or using some identities to manipulate and rearrange. Okay, so that's that done for this topic. I'll see you guys in the next one.